Good to go? All right. Hi, everyone, and welcome to today's talk on deserialization. The obligatory slide about the speaker. My name is Alexei. I started my career as a software developer, but then at some point I realized that breaking code was more interesting than writing code, and I decided to become a security guy. And I've done application security for the last several years, working for a few companies, and I currently work for Salesforce in the United States. So today we're going to talk about deserialization, what it is, different formats. I'll give you several demos, and I hope they work because you know how it goes. You try them multiple times at home, and they don't work when you present. But I hope we don't have any issues today. Well, I want to give you live demos because I think that's a good way to demonstrate the actual things happening in real time. And I don't know about me, but when I hear the word exploit, I want to see the exploit, right? So I hope you do too. And we're going to talk about some big vulnerabilities that had insecure deserialization as the root cause. And we'll, of course, discuss the ways to fix the issues. So, as you know, insecure deserialization was added to OWASP top 10 a couple of years ago at the end of 2017. And shortly after that, at one of my previous jobs, I was asked to create a small online class on the topic. And I started looking into it and I thought, hey, it's kind of boring. You know, there's not much to talk about. But as I started looking into everything that's available online, I realized that the topic is huge. It's very deep and it's very broad. There are multiple languages. There are multiple formats. There are many different ways to exploit, to attack, and many different ways to protect. And they all depend on either language, the format, or the combination of those, or some other factors. So since then, I've done 2 large presentations on this subject, and this is my 3rd one. And I don't know, I still don't consider myself an expert because this is just too much for, for a single person to absorb. But today, I hope you leave with some idea about what deserialization is, specifically how it can be dangerous, right? And why we want to fix our issues. But first of all, what it is. Let's say you have a program with some kind of an object in its memory, and you want to send that object to maybe a different program. The way it's normally done, that object is converted to some kind of a byte stream, and then you send that byte stream over a certain channel. It doesn't really matter. And then on the other end, that byte stream is deconverted and to create a copy of that object in maybe another program. So the first process is called serialization, and the second process is called deserialization. And your channel can be anything. It could be local storage, it could be network transfer, REST API, parameter, whatever, where you can push the bytes, that's where you can push that object. In terms of different formats and languages, we can talk about binary formats, and those are normally related to languages that support serialization natively, like Java, Python, or .NET. And we can also talk about human-readable formats, like XML or JSON or any XML-based formats. And if you think about it, if you look at the XML, it's basically some kind of an object, right? It has tags, it has attributes, it has some data, and it's human-readable. You can look at it and understand what's going on. With Java and Python, for example, it's binary. You don't really, if you look at the file itself, you don't really see exactly what's there. So with that, so this is just a small subset on this slide. You can go to Wikipedia, for example, to get the full list, and there's a lot of different formats. And you can see right away how broad the subject is, right? Okay, our first demo, very basic stuff. Let me see if this microphone stand works. And if I can find the right window, here it is. So I have a small Java program called BasicSerialize. I hope you can see it. So what it does, it instantiates an object of a certain class. The class is called just a class. It's a very simple one. It only has two members, ID and name, and constructor and a toString method. So we have that object in the memory, and then we create a couple of things like file output stream, object output stream, and then we finally call a method called writeObject. And that's the method in Java that serializes an object. And we write the output to a file, and then the second part of the program reads that file, creates file input stream, object input stream, and then it finally calls the readObject method to deserialize. So that's the actual deserialization right here. And then we cast the result into our class. All right, let's see how it works. So the program ran, it wrote the object to this file. And this file is 81 bytes on the disk. And if you just look at it, it's some kind of a binary garbage, but you can also see some plain text, like the value of one of the fields in the object. Even the class name is here in the plain text. So even though it's binary, you can still see some data here. If we try to base64, the first 5 characters read RO0AB. And if you see this kind of string in your burp log, you can guess that this is probably serialized Java object. So that's a nice thing to remember. Let's switch to Python. With Python, I have 2 very small programs. One is save, and it creates a very basic Python dictionary with a couple of values. And then it uses the pickle module and its dump method to serialize that object and write it to a file. And my read program is doing the opposite. It reads the file and uses the pickle module and its load method to deserialize the object. So if I run save, it wrote the object to file. If I run read, it read the object from a file. Again, if we try to just print the file, it's some kind of binary stuff, but just like in Java, you can see some plain text. So it's not like encrypted or compressed or anything. It's just really the data as it is. That's pretty much for the basic example, and we're going to move into maybe more interesting stuff. Everybody's favorite session cookie. All right. This web application has a couple of sections. Let me make sure I don't have anything here. Insecure and secure. So let's go to insecure, and it says, I'm not an admin, go away. Secure pretty much says the same thing. So they act identically right now. So let's take a look at our cookie storage. So we have 2 cookie values, the insecure cookie and secure cookie. One of them, you see they almost the same, but the secure cookie is longer, and we'll understand why. So let's take a look at this cookie and see and try to understand what it is. It seems like some kind of base64 encoded value, right? Reasonable? Okay. If we just echo this, and of course we need to replace this with actual characters. If we decode, it's a plain JSON. And it has a couple of values, one for name and one for the role. And I could guess that this role probably something that tells the web application who the user is. And what if I do something like this? Replace anonymous with admin. Cool. And if I base64 encode it, now I have my new base64 encoded JSON And I can probably try to replace this cookie with this new value. And now I refresh the page, the application read that cookie value, and now I'm the administrator. And of course, I mean, this is a very silly example, but in this case, the application did not care about the data integrity, basically. It trusted everything that the user supplied. So even though the application generated that cookie in the first place, it gave it to the user, and the user was free to do anything they want with this value. So as we know, no integrity, no security, right? So for the data that might end up in the user's hands, we always need to make sure that we do some kind of validation. And we can do, for example, digital signature, sign that value with private key, or we can do a message authentication code like HMAC. And in my case, I used HMAC with my super secret key, which is only known to the application itself. It's never revealed back to the user. But the app now signs, well, not signs, but adds that HMAC to the cookie value. And that's why the secure cookie is longer than the insecure one. It has two sections separated by this little dot right here, if you can see it or not. So the first is just the value itself, and the second is signature. So if I try to replace the value with my new forged admin cookie, then if I go to secure section, I just get unauthorized. So the application properly checks the authenticity of that value. So that's the first thing that we need to remember. Always check integrity, authenticity, unless you really trust the source, which frequently is not the case. Okay, another demo. This time we are going to use a Java application. So let's say we want to make something and sell something. So we would go to factory and order some items. So we found a factory that makes all things. And how about we order 1 million iPhones? Okay, awesome. So we got, they produced 1 million iPhones for us, and they send us the package, which is this file. And let's store it on the disk. Now that we have that package, we can send it to the store so they could sell it for us. So I click the sell button, and they instantly sold 1 million iPhones. This is awesome. This is better than Amazon. You have to wait there. Instant delivery. Instant delivery, instant profit. So what is this object that they sent to us? If I use the Linux file utility, it tells me that it's serialized Java data. Yeah, who could guess, right? Anyway, so all is fine, and I can order some more items and some more items. But what if the factory is malicious, and instead of iPhones, it sends me something else? So this factory is just a bunch of hackers who do malicious things. So instead of my Tesla or whatever I want to sell, they send me a string, a 64 gigabyte something, and then a CPU bomb. I'm going to store all of them. And if I look at them on the disk with a file utility, they all serialize Java data. And they're all pretty small, you know. The biggest one is just a few kilobytes. Cool. Oops. Let's try to sell one of these things. So if you try to sell the string object, we get a Java exception, which is kind of expected, right? Because it's not the object that the store is able to deal with. right? And the exception says that string could not be cast to the class items. Good. All right. And the exception was thrown on line 21. So let's take a look at line 21. And this is our read object method, as we saw in the basic example. That's the one that is doing deserialization. But I want you to pay attention to the actual exception, which says cannot be cast, right? So that means, if we can read the Java code, this is the casting right here. So that tells me that read object actually did return. It succeeded. We failed here on the next step. So that tells me that deserialization did happen, even though the object was completely of unexpected type. So to prove the point, let's try to sell these other malicious things. So let's try to sell this 64 gigabyte object, even though, as we saw on the disk, it's just I don't know, 100 bytes, right? Why is it selling 64? I don't know. And if I try to sell it, my application thread crashed. And why is that? The reason is this little object, and it's right here, it's trying to consume 64 gigabyte of RAM. And of course, I don't have 64 gigabyte of RAM on this little virtual machine that I'm running on my laptop. So there's no way I can do it. Well, that's great. We crashed the application. Well, in this case, we crashed just one thread. How about we try this CPU bomb? What is it? It's going to crash. It's going to throw an exception. So I sell, and it's not returning. So what's going on? And I can hear that my laptop fan is running really fast now. So something is using my CPU. Oh yeah, it's really loud now. So this is the virtual machine where this application is running. If I run my top command, I can see that this Java process is using 100% of CPU. Actually, it's more than 100. I don't know how it's possible, but whatever, right? So it's using all the processor resources. And what is this process? 2417. This is my Tomcat server. So that's the server that's running all my Java applications. And now it's really busy deserializing that little object. So for whatever reason, and this is the code for that that object. And it's not my code. I stole it, of course, from OWASP page. I borrowed it. Okay. It's some kind of a structure, looks maybe like a tree, 100 levels deep, based on hash set, standard Java type. And apparently, JVM is able to create this kind of object and serialize it just fine. But when it tries to deserialize it, it gets really confused. And it will never return. So it will sit here spinning my CPU indefinitely, in an infinite loop. And the only choice I have right now is to kill my Tomcat or restart it. Bye-bye. All right. Yeah, I could just run this. Okay. The website is up and running. So how can we solve this issue if deserialization is happening no matter what? Well, there is a way to do it in Java. Again, this is very language specific. So in Java, what you need to do is you need to whitelist the class type. The way to do it is, instead of the plain object input stream, you need to extend it and override this resolve class method. This method is called automatically during deserialization, but right before it happens. And what I'm doing here is I get the class name of the input and compare it to the class name of the class that I expect to see. And if they don't match, I throw an exception and I fail gracefully. So let's see how it works. We have a secure store with fixed code. If I send it, let's say 64 gig thing, it tells me they do not accept Java-like objects, Java-like object. It's like store telling you we do not accept Visa or MasterCard, right? Same thing. Or if I try to sell the CPU bomb, they reject it too, saying we do not accept hash set. Cool. All right, we just talked about it. Class-wide listing. Okay. Crashing the application or causing some other kind of denial of service attack is great, right? And many attackers are trying to do just that, but most of us would want to run code on the server so we can own it completely. So let's see how it can be done with Python. I have yet another application written. Let me clear the cookies. And so it's written in Python and doesn't do much, but it gives me a session cookie again. And here's this value. Again, it's some kind of base64 encoded thing. And since it's written in Python and we're talking about deserialization, guess what that cookie is? Any ideas? It's a serialized Python object. So if we try to decode it, we get some kind of binary stuff, right? But what if I write it to a file and then use my basic Python deserialization program to read that file? It read, and it's a Python dictionary, right? With a couple of values again. And we have access value, and here again, we can spoof it because there is no integrity check on the application, but that's not what we're trying to do this time. It's not interesting anymore. We want to run stuff. So the way it can be done in Python is every time you serialize an object that object of a class that has a method called reduce or __ reduce, that method will be automatically called during deserialization. And I don't think there is a way to block it, basically. So if I serialize this object, this OS system command should be run on the server. And this is, of course, a netcat-based reverse shell. So let's give it a try. I'm going to run my payload program to generate payload. So this is a base64 encoded, serialized Python object, and I'm going to replace the cookie with my own stuff. And before I refresh the page so the application processes that cookie, I'm going to run a netcat listener. Refresh. Let's hope it works. Yeah, we got a connection. So what is this connection? Let's see. We are in this directory and we are root. Oh, awesome. So the application is not configured well. It should not be run as root. Yeah, pretty much. Again, so you can imagine what we can do now. We are the gods on this server. Cool. How can we protect the application in this case? Well, in this particular case, we can verify the integrity or authenticity of that cookie, right? But if you want to accept some arbitrary Python object, we just should not do that. Okay, let's switch the topic a little bit and talk about some big vulnerabilities in the last few years that had insecure deserialization as the root cause. The first one I want to talk about is Apache Commons Collections remote code execution. So let's say you have a web application that is using several libraries on the backend. And one of those libraries happens to be Apache Commons library, or Apache Commons Collections, actually. That library has a bunch of reusable Java classes. It's very popular, and many applications are using it. What happens is if your application is accepting user input and deserializes it, then a user can supply a certain object that would use so-called Apache Commons gadgets. And the topic is very complicated. You can find presentations on it. They're like 1 hour long each. We're not going to go into all the details. But basically what happens is this is a sample sequence of the method calls that's happening when such gadget chain is deserialized. The things in bold are the classes and methods from Apache Commons library, but we also have some standard Java stuff. And right here we can see that we get runtime. And right here, we call runtime.exec to execute OS command. Is this a problem with Apache Commons Collections library here? No. The problem is with the application that is not whitelisting the class types and is just accepting the user input without validating it. So in this case, the Apache Commons project was forced to fix and to remove some of these risky methods because the big applications from huge vendors, very important players on the market, were using the library, and they said, we need you to fix it, otherwise we're all broken. So they had to fix it. But the problem might still be there if they did not make the fixes themselves. Okay, the next one is Apache Struts REST plugin, remote code execution, again. In this case, we're talking about Java, but the serialization format in this case is XML. So this is on the screen here is HTTP request with the exploit. As you can see, the body is XML file, but you can also see some Java artifacts here. And here is Java process builder and a string which suspiciously looks like a reverse shell. In fact, it is a reverse shell. So what happens is when this REST plugin deserializes this object, it creates those Java objects and calls a method to execute a command. Yeah, Java code within XML. What can go wrong? The next one is pretty recent in Oracle WebLogic. So in this case, it's also XML-based format and very similar to the previous one. We see process builder and a string that with the bash call to remove all the files from the system. But we could run anything else. So when I went for this particular one, when I went to look for actual exploit so I could try it and get the screenshot, I went to Metasploit and found 4 other ones. And it looks like Oracle WebLogic was having issues with deserialization for years. So there's one from 2015, 2016, 17, and 18, and 19. So each year they have vulnerability and published exploit, and they have to fix it. I hope they finally get it right. But the problem is difficult, right? Okay. No more Java. Let's talk about .NET. CyberArk, if you don't know what it is a product. It's like your enterprise level password manager, right? So this is the quote from their website. They help you secure, rotate, and control access to privileged account credentials. Very important stuff. And they have this useful REST API for automation and I don't know what else. But It's authenticated, of course. Authentication token happens to be a serialized .NET object. And there's nothing wrong with that, as long as it's done right. But it had a couple of issues. First, it didn't have any integrity protection, so anybody could spoof anything. But it was not the biggest issue. The biggest issue was there was no class type validation. So you could submit an object of your own type. And just like in the case of Apache Commons collections, you could create a .NET gadget chain and get remote code execution. So when the researchers found this vulnerability, they reported to the vendor. The vendor promptly fixed it. The researchers published. And here's the actual exploit. You run just one command. You use an open source utility called OWASP. In this case, it's OWASP.net to generate the payload. And then you supply that payload as authorization header, and you run curl command to execute that code on the server. Is it difficult? No, anybody can run this. In fact, let's try. Unfortunately, I do not have CyberArk, but I wrote my own application. All similarities with existing products are purely unintended. Yeah, it's just a coincidence. So this application has a very cool REST API with just one function. When you call it without any parameters, it gives you a sample value. And when you see something that begins with AAE, AAD, that's most likely a serialized .NET object. That's, that's how they are. So, I'm lost. Okay. So if I call it without any parameters with a curl command, I just get this sample value. But what I'm going to do is I'm going to generate a payload using this utility that the researchers did in case of CyberArk to run calculator. And of course, every attacker wants to run calculator. And then I'm going to supply that payload as authorization header with curl command. And I've got my calculator. Yeah, now we can play with it. Of course, it threw a whole bunch of stuff here as the output through an exception, but who cares, right? We have our calculator. Mission achieved. Okay, so to conclude, as an attacker, what are your tools? So first of all, you might want to reverse engineer. You might want to understand what the application is doing, what data it's processing and how, and where it's getting them from. So you can use any tool you like, right? And it really depends on the type of the application and whether you have access to the source code or not, and a bunch of other things. There is a very great tool called OWASP that was originally written to, I believe, to demonstrate those Apache Commons collections gadgets, but since then it was expanded a lot and now has many Java payloads. OWASP.net, which we just used a couple of minutes ago successfully, is a similar payload generator for .NET. And there are several burp extensions. Last time I looked, I think there were maybe 5 or 6 related to deserialization, and you can use them too. And of course, you're welcome to write your own code. And you might want to do it because you might want to create your own object with your own malicious payload to run. And none of these tools might be working. Or there could be some obscure language that you want to cover, that there's no tool available. So takeaways. Deserialization is, it can be dangerous. So don't use it. I mean, seriously. Well, okay, I understand we have to use it sometimes. So if we do, we need to do it in a secure way. So first of all, we need to validate all input. Because as we know, the broken deserialization can result in broken authentication authorization, privilege escalation, denial of service, and even remote code execution. So if you don't want any of this happening, we need to either process the input correctly or just plain reject it. Or just don't support it, okay. And remember that the third-party components can be vulnerable. If you're using one of those, like 2 years ago, if you were using Apache REST plugin, you would be, your application, even though your source code is completely secure, it's still vulnerable. All the code, all the demos I showed today are on GitHub. So feel free to use it. It's a Vagrant machine. So you run Vagrant, and in 20 minutes, you have a running machine with all these apps, except for .NET. You have to have a separate Windows machine for that. I could not fit it into a Linux box because I just couldn't. Feel free to use it, share it with anybody else, use in your presentations or to teach somebody else. You can contact me on Twitter or LinkedIn. And thank you very much. I don't know if we have 2 minutes for questions.
We've got plenty more for questions.
Okay. One of the countermeasures you present is to have whitelisting of the class name. Do you have an opinion on how effective that is? Because can an attacker not just wrap his code inside that class name? Yeah, it's not just class name. It's not just a string. It's more like class signature. So if the program does not know about this class, even if it has the same class name but different, it comes from a different. Okay, let me rewind. If you're using the same class, the valid class that the application expects, then you can deserialize it safely, right? Yeah.
Yeah. But if you create a different class with the same name, but with different members or different methods, then it will have a different signature. And that's what that method is checking. So it's not just checking on the class name, it's checking on the class signature.
Okay.
You also mentioned validating the input, but my question is, don't you just need to serialize first so then you can validate what's inside the object?
Great question. By input, I mean you get this base64 encoded value, right? And you can unpack it so you can base64 decode it, see what it is. And then you might want to check the digital signature or HMAC, right? So that's what I mean in input validation. So it might be multi-step process. You might want to check the integrity first, authenticity, or then like in case of Java, we were checking that class signature right before deserialization. So it's part of deserialization, but happens right before it automatically. So yeah.
Okay, thank you.
It's also work when I let my application run with these privileges. Maybe I cannot open the API when the application doesn't.
The question is, do you have issues with if the application is run with least privilege principle? So it's not running as root, right? Right? Yeah. The other question. Well, it really depends. Normally, the account that's running the application is capable of doing something. It might be only capable to reaching out and issue SQL requests against a database, which in attackers' hands might be dangerous, right? Or it could change the state of the server, right? It really depends.
But it could be a mitigation.
Yeah. It would definitely help, but it's not specific to deserialization. It's a good practice. Lunch? All right. Thank you.
Thanks.